Chat. Okay, so yes, please. Okay, again, be Friday. Welcome, you guys. We'll have a live session. So, I hope that this lesson will be helpful to you. That's my hope. But helpful, okay? I don't know who's about helpful in the mind, but I will try my best to just be helpful. Kake ndisalungisa izinto zami kaloku andiqhelanga uba ku-YouTube ngoku, so ndisazama ukuzilungisa nam kakuhle, ndizisete kakuhle into zam. Kuvele only the things that just you are supposed to see. Ndingathi ndiyasokola nje. But I'll try to make it work. I'll try to make it work. Senda ilink unixela nje abantu baziyo that I am alive for a lesson that I think is going to help you. You can send the link around. Hopefully you'll be helping someone. So I've prepared some few lessons, a few exercises or problems. We'll be able to cruise better together. Number one, I will start with his springs. Today, I'm trying to do only 2 sessions. As I'm going to springs and Mohr circle. Okay, stress transformation. I'll do only those 2 sections. Now, you do have those handouts that I gave you about they were about You have in preparation ka test 2. So I got them. You can go ahead and check them out. Okay, so let me just do this. Hello, it's me. I'll be teaching you just springs and also stress transformation. So those are the 2 lessons I will be doing today. Those are the 2 lessons I'll be doing today, only 2 of them. Then if I have a chance at night after around 10ish, I can do the last one, which is this frameworks. I can do frameworks at night to night. Then after that, can you have a new practice and get ready for the test. All right. So let's go ahead and check out bangabasa kuyenza kanjani. I hope I'm audible. Okay, so if for example you have a question, you can send it via WhatsApp. That will be fine. You can send it via WhatsApp, or if you have a lesson, a question, I will answer your question. Okay, going to add questions. Okay, let me try it. Yeah, what's a question? You can just say that, okay, man, for now, normal thing. So let's start with springs. So for these springs, we do have these coiled springs. We do have easy that can be asked in general questions that you may expect. But baby question. I hope sound yummy clear. Still as questions. As the questions is zizobe zisithi mhlambe, for example, calculated deflection. Now, okay, maybe they want if shear stress, so that will be shear stress as usual. Then bangafuna deflection. So deflection for us, it will be X. Now remember, let me just go to equation papers zenu so that nizokhumbula ukuba ngaba ku-question papers i-formula sheet ime kanjani. So we will have X for deflection. We will have U. What is that? Strain. Yes, strain. Because as a strain, Yana is the strain energy. That's the energy. It's actually not just the strain, it will be strain energy. So we'll have OU for strain energy. Then we will also have UK, which is the stiffness. We'll have diameter of the wire, that is a small letter D. We will also have a capital letter D, which will be the coil spring diameter. Now, a coil spring says must be round, so it's actually the real coil. So that is why we'll have that. Then we'll have N as a number of coil. Work done is equal to U, that is the work done. So, for example, if you can see upper with formula sheet izabe ime kanje le type ye-springs. So if formula sheet ime ngohlobo kule ndawo, we know that this is for shear stress. We know that upper the cables, formula the cables, upper the beams, then upper the thick cylinders. So we'll go to page 3. So page 3 deals with springs. So these are the formulas as under springs. Now, as formulas, as we will have number 1, the first one, which is shear stress. Of course, if you can open your formula sheet, you'll see that now shear stress. Now, kula shear stress, you can see we have this part with brackets. That is the one that we'll use most of the time. Then we have this K. So this K is actually this one. It can be KS or KW, depending on the question. If they are talking about a torsion, then you'll use UKS. You'll use UKS if they deal with torsion. If they are talking about EWAF effect, or they are talking about the other word, okay, I just forgotten now, but I think Konum Zagero was asking this, so you'll have the second K if that's a WAF effect. Now, for you to be able to use, you're going to get log K, obviously you'll need to have this C in order for you to get K, because you're born C corner throughout. So for us to get OC, this is the formula for OC. It will be the diameter of what? This diameter is the one of the coil, then this is the diameter of what? Of the wire. Now, a coil engine, you know that a coil spring, it's like this. I'll just draw a rough diagram. Now, this is the wire. So la wire liya ine diameter yayo. Then bekhona this diameter ke ngoku le izaba ye spring itself. So that's where we have a capital letter D. Then that diameter of the wire is the one with a small letter d. I hope that one makes sense. So this is what we have. That's the distinction in OD, Nalawa OD. So basically, this is what we will have in this topic. Of course, we do have another formula for shear stress, which is this one, Z2. We have that one. We also have this one. Then we have a formula for X. X, I said it is a deflection, la X. Then we have UC. We have UU. We say UU is our energy. So it's a strain energy. It's the one from N5, strain energy. W is the weight. X akachange i-deflection. Masengixesha zonke inosi zethu. K, we can use like K. If but like a torsion, we'll use that one. If they talk about a WAF effect, we'll use the second one. That will be for a WAF effect. That can join a question. Let me just check the question quickly. I'm going to check a question that will talk to you about considering torsion, including direct stress, by including a direct stress. One is curvature. If the question they are asking, find shear stress for the curvature, then you're going to use that K. So the K color is only for torsion and direct stress. Then the second one, it will be for curvature. So we do have UW. UW is for the load or the force. UD, the capital letter D, as I've said, it will be for the diameter of the spring. Then small letter D, it will be for diameter of the wire. Now get small letter D underneath. Okay, then we have UG. UG, it will be measured in gigapascals. The other things siyazazi, small letter D siyamazi, capital letter D siyamazi. N, that N, it will be for a number of coils. So that's what we will be having. Yeah. So then this is U, W siyazi, X siyamazi. K is the stiffness. X is still deflection. Then yeah, so we have three formulas for UU. All of them, they have the same effect, all of them. Then we have this K, formula K. Now K is stiffness. Now sometimes we can talk about from the K is this way, yeah. We know UG, we know UD, small letter D is for the wire, capital letter D for the spring itself, for N number of coils. Now coils, obviously, these are coils 1, 2 in this case. So the 2 coils in this spring that I drew, but the number of coils, it will be the number of windings. That's basically what they mean, number of coils. So that's what we have. Then we have K, this K, this K could be, this one will be when we are connecting these springs in series. Sorry guys about the noise. So abasine connection ka series, then apha sibe ne parallel connection. Okay, I sorry about that. And as the network yami iyaqhawuka, but I'm back again. So this is what we have. Yes. Then let's go to E formulas. We can see how to apply these same calculations on springs that are joined in series. So for a series connection, we'll have E weights, they will be the same. W1 is equal to W2. Then secondly, when you talk about E deflection, they will be different. So you'll have to add them up. When they are joined in parallel, E weights, you have to add them up, forces that are applied to get a total force. Then on this side, the deflections, they have to be the same. Then finally, I again wrote something. Again, this is a connection, a series on this side. This is a series connection. So we said that weights should be the same. A deflection, you have to add them up. Then this is the upper. This one is okay, which is stiffness. For stiffness, we will have this for series. Then in a parallel connection. For a parallel connection, stiffness, you are adding them. Deflection, they will be the same. Then you weight, when you total weight will equal to weight for the first one plus the second one. That's what we'll have. Now you can see that for E energy, it will be the same for both of them. Formula for total energy, you are adding 1 and 2. When the connection is in series, you are doing the same when the connection is parallel. You are adding 1 and 2 for energy. So that's what you should know about as formulas. Then if you go to your textbook, you will have a list of formulas. I try to write them down. As important, these indices are reddish. So for example, to find the angle, this one, and you can see this one is not part of the ones you have with formula sheet. So that's why I wrote it. I wrote the one for E length because it's not part of a formula sheet. Also for E volume, this is red because it's not part of a formula sheet. One formula sheet, it is the one of a torque. So that is why it is red, because the torque is not part of your formula sheet, but maybe you can use that one. So the ones you can use, but they are not in the formula sheet, these here and these are red. Yeah, now see a picture. Yeah, so you can take a screenshot for this part. So that was born the ones that you will need to use, but they are not part of the formula sheet that you have with you. Okay, there's almost on the light here. I'm a bit close. Better. I hope I'm doing something helpful. Okay, so you can take a screenshot silent iPad, then it's going to be helpful to you. Okay. All right, now let's go ahead and do some exercises. Okay, you can see Bangaba. I already talked about these ones. The back formula sheet. I already talked about them. The K, but K can be this K or this K, depending on what is asked. If they want only curvature, you'll use this K. If they want, for a curvature, you'll use this K. But if they only want for a direct and torsion, you are going to use that K. That's it. Okay, that's basically it. Now we will move to, okay, a pattern by series on this side and parallel on this side. So that means you can also take a screenshot, say paper. Then I will go and look at some questions that I've prepared for you for this topic. Prepared just few questions for you. Okay. In your pamphlet, I gave you a pamphlet for preparation for test 2. Particular preparation for test 2, I have some few questions. For example, 1.18. But when test 2, guys, please go to the side of test 2, not 1.18 for test 1. 1.18 for test 2 on the side of test 2. You can go there and find that one. Remember, I want to help you out, so please work with me. So 1.81, let me read it. I hope number, but that's what you are seeing. It says a closed coil spring, helical spring has a stiffness of 8 kilonewtons per meter. The spring is made of 6 millimeter wire and has 12 active coils. Assume G as 85 gigapascals. That's what you have. That's the first question. Okay, I wrote down the data right here. That is that question. So 1.18 on the side of test 2 prep. 1.18 on the side of test 2 prep. Okay, now I'm starting. Ubake usemva usheke wedwa ke guys, because I'm moving now. I'm starting to move. If you have a question, unganithumela pha ku WhatsApp. You have my number WhatsApp. You can just send your question by WhatsApp. But also subscribe in lapha kule live yami anyway. At least that will boost yabona confidence yam now. So let's go ahead and do so. We have this K, we have UD being 6 millimeters, small letter D. We have N active coils, 12. We have OG equaling 85 gigapascals. Then we are asked to calculate, number 1, the diameter, for the mean diameter of the spring. That's number 1. Number 2, which are the shear stress for the deflection of 20 millimeters. Now they are telling you that X is equal to 20 millimeters. Then we have number 3, the next question. Now, oh yes, it continues to say, consider torsion only on this one. Considering torsion only. Now, when you're considering torsion only, you will not include la K. So number 3, Bati, this time the resultant shear stress. The moment we can get resultant shear stress, that means you are going to have that K. In the formula sheet, remember formula sheet yako, you have this K. So the moment you can get resultant, you'll include this K. Now, before the 2 about the resultant, you can only take the part that is inside the brackets. Only that part you'll use for your calculations. But now they included, okay, that means you are, if they're saying a resultant, as they said here, a resultant, that means you're gonna include that K. Then the next one was, again, I'll the resultant shear stress by including the direct and the curvature of the spring. So that means you are going to use kW this time. Then number 5, they want strain energy. So they want strain energy for number 5, strain energy absorbed by the spring. Then the next question, which is question number 6, they are saying the number of coils required if the deflection must be limited to 15 millimeters. So that is what you have. So let's go ahead and answer this one. I'll show you, of course, a skeleton as usual, give you a skeleton on how to answer it. Okay, so let's go to the formula sheet and check out our formulas. What are we going to look for? We have this data. So we're looking for what is given in the data. So we can see that in the data, we have G. We do have G, no D. Do we have N? Yes, we have N. We have N, but we do not have U bigger D. It's the one we want, and we do not have that one. So we'll skip that. Bigger D is what we have. We have X. No, we do not have X. So which one can we use? What do we have? K, we have G, we have D, small letter D, we have N, we only need, so that means this is the one you can use because the only unknown is the capital letter D, and the question wants the diameter, the mean diameter of the spring, which is that capital letter D. So this is the formula we are going to use. So that's the one I will write down. To answer number 1, we'll have K equals G D to the power 4 divided by 8 D cubed times N. That's what we have. Now we can make, obviously, UD the subject of the formula. If you're making UD the subject of the formula, remember, we are divided. So that means this will go here, that will go here. So now on top, there is no change, divided by 8kn. Then this D is raised to the third power. If it's raised to the third power, that means we are going to look for the third root of that. So this is the formula we're going to use to find that D, because we have everything. You have G, you have D, small letter. Now remember, if I did not write the unit and it's a measurement, it is because it is in millimeters, quadrowing, you know that. So that is 6 millimeters. So you multiply to the power -3. Change it to meters first. There is given in kilonewtons. Then you have N is just the number. So in number, it has no units. It's just the number of coils. So this is what we have. The only thing that changes units is ion giga. So that means to the power 9. This is to the power 3 because it is in kilo. Then that one is to the power -3. So that's what you will do to answer the first question. For you guys, answer. Okay, are there any questions? If you have questions, ask me. I have a WhatsApp number. You still have my WhatsApp number. But now you'll have it someday. So you can ask that question on WhatsApp if you have a question. If you are fine, okay, that's great. You can move to number 2. Now, how are we going to number 2? We're looking for the shear stress. That's the one we need. So the formula to find is shear stress. It is the one you know from here. That's the one. You can use this one. You can use that one. It depends which one you want. Okay, but yeah, we can use this one. You can just use that one. You'll get the answer. Any of these will give you the answer. Now for this one, you will not include that K on this one. Not going to include K. The reason it is because they are all saying you are only considering one thing, that is torsion only. So if you're considering torsion only, that means you will treat it as a normal shaft. So that's what we have here. So we are not going to include K. Let me just write the formula to make sure that we are going together. Let me make it a bit bigger. So this is the one. Okay, we're not going to put it. You're only going to use this one, or you're going to use this one. Both of them, suppose they'll have the same answer. So we can go ahead and do so. X, G, D small letter, pi, D squared, capital letter, times N. You can use that one, you'll get the answer. Or you can use the one on top. The one on top. So how are you going to use this one on top? Then first things first, we must first find that W. So it could be a long root, but I want you to use it so that you can check if the answer will be the same. So let's go ahead and look for W. So for us to find W, which formula can we use? Well, the one that is straightforward is that one. We do have K, they gave us so X, but X would 20. So we do have K, we do have X, so that we can be able to find W from that one. Then after finding with W, we can go and substitute by that W there to find stress, and then remove that K. It's not needed. All right, so let's go ahead and do so. K is equal to W over X, which is obviously, now I'm going to make W the subject of the formula, that is Kx. You find that W. Then after that, you come and find shear stress using this formula. By the cubed. So that's what you will do. Okay, let me try. Yeah, that's it. Okay, so you can use any of these. The answer will be the same. Any questions? Any questions? We will move now to the third question, that is simovela apha ngoku. All right, let's go ahead and try to answer number 3. Resultant, but they are saying that it's only for torsion and direct stress. So it's only for those two. Okay, if it's only for those two, then that means this time we are going to use this K, but we will use this K as Ks, meaning that we need to first find that C, because we don't have C. This is 1, that is 1, we only need to C. So let's find C. If we do have a formula to find C, by the way, formula to find C, there it is. C is equal to capital D over small letter d. So we will be able to find C, and then find that Ks. That's what we'll do. So that is number 3. Number 3, for number 3, we said that we are going to use, okay, let's find C first. C is equal to D over D. We just calculated UD there, so you'll find that ratio. Of course, UC is a ratio because it's millimeters over millimeters, so there is no unit for UC. All right. Then after that, now we are going to include Ks. So Ks is 1 plus 1 over 2C. And we just calculated UC here. I hope that makes sense. Then now we will be able to calculate a resultant. So resultant 1 or whatever resultant, or resultant S, it doesn't really matter. So resultant 1 will therefore equal to Ks into 8WD over pi d cubed. Remember, you already have this answer, isn't it? You calculated it here. So you just put that answer there, or you can just write it as is, but you already calculated it here, so you have that answer. You can just put that answer as it is, and then you multiply it by that Ks. That's how you will get the solution for number 3, which is the resultant shear stress by including the direct stress or the direct shear. I hope that makes sense. Any questions? Okay, I don't see any questions about WhatsApp, so that means there are no questions at the moment. So let's move to number 4. Let's move to number 4. So the next question says the resultant shear stress. So again, it's looking for a resultant shear stress. So that means now this will be resultant number 2, because we dealt with resultant number 1. Okay, the resultant shear stress by including the direct shear and the curvature of the spring. Now, obviously, I said when they want that, you are going to use the KW. Sometimes they may say the WAF effect. So we're going to use this KW. So let's first calculate KW. So KW is equal to 4C minus 1 over 4C minus 4 plus 0.615 divided by C. We are using the same C. We are going to use that C. All right. Then after that, we can now go and find AW of the same thing, 8WD over pi d cubed. So then nothing else, because this you already calculated above. So you're continuing with it. Okay. So as I've said, for now the one for the closed coiled helical springs, then the second one that I'm going to do, it will be transformation of stress. Those are the two. The question wants us to find absorbed by. Remember, we have this one. We do have K. We also have X. There's another one which is a lot complex. There is another one which is W and X. So you can use any of these. Any of these you can use. So I'll just take basically any. So that is number 5. Number 5. So for number 5, we'll be calculating strain energy. You can use any of them. Wx over 2, that's fine. W calculated, W right there. So you have W. Then you have X. X was given as 20 because now these calculating from 2. We're calculating X being 20. So we'll use that and then you'll find the answer. You can use that one. Obviously, you can use this one as well. You have K, you have X, you just square that X. So any of these will work, right? Do you think this is informative? The class is going to be informative to you. Now we want to answer the last question. We're moving to the last question. Is informative. So let's go ahead and answer the last question. Now they want a number of turns or a number of coils of these springs. Which formula are we going to use to answer this? They are telling us that we have a limit. So of X. X is equal to 15. Okay, this could be very helpful. This could be very helpful. We have X there, now it's 15. G is there. D, we have a value for D. For both G's, the small and the big, we have the value for W. We only need N because they are asking the number of turns if X is like this. So we'll use that formula and make N the subject of the formula. So let me go ahead and do so. X is equal to 8WD cubed, bigger D, times N, divided by G, D to the power 4. Now, obviously, we'll make N the subject of the formula. Then I'm going to say first subject of the formula, like N, the other side. So we'll have X, G, D to the power 4 divided. So all of that will just go and divide 8 WD to the power 3. And then that is the answer for N. That's the first question. That is 118 on the prep questions for test 2. Any question? Remember I said that tomorrow I will do the last part. Oh, I said that tonight actually by 10 p.m. I'll do the last part so that tomorrow you can do all your exercises by yourself. I won't interfere. I won't interfere. You'll just do everything by yourself. Yeah, and I hope that nizakwenza kakuhle. Okay. Any questions? Any questions? Any questions? Any questions? Sorry. Right. then move to the next question. I'll just give you a few minutes. If you want to take a screenshot, Salendo, is it going to fit? I think it's fitting. If you want to take a screenshot, Sayo, you can, before we move to the next question. I'm telephone here, chat. Hey, chat. Oh, yeah, chat. Good. So right away, let me move to the next one, 119. I started with 118. We are done with 118. Now let me move to 119. I can't need by the party data. Okay, so we are going to write data for 119 together. So I'm moving this one, moving it away. So we'll write data for 119 together here. Nancy, data. Let's take down the data. It says a composite spring has two closed coiled steel spring. So both of them are made out of steel. We know now. Connected in series. Now we are talking about a connection. So they are connected in series. And it goes on further to say, now, what do you know about series connection? The most thing that will come to my mind about a series connection is this right here. I know that series connection, I have this, this, and that. So that's what comes when we talk about a series connection. Even before we start to answer the question, that's what should be in your mind. Okay, series connection, down the data. So they're connected in series. Then one of the spring has a minimum. Okay. One of the springs has a mean coil diameter of 50. Now we are told that one of them, a coil spring diameter, it is the capital letter D. So they are telling us it is 50 millimeters. So I'm not going to write millimeters because it is in millimeters. Then they are saying, and a wire diameter of 5. Then small letter D is 5. That's the wire diameter. Then after that, they are saying, and has 10 active coils. So you know that N is equal to 10. So this is 1. Right? But the other spring has a wire diameter of 3 millimeters. Now we're moving to number 2. D2 is equal to 3 millimeters and 15 active coils. Then N2 is equal to 15. Then Bachi, take G as 82 gigapascals. So we know that UG, because they said this is a steel, will equal to 82 gigapascals. Then Bachi, and the shear stress is limited to 100. Now its shear stress is there and 100 megapascals. This is what we have. Then we are going further to calculate. Now we want to know what to find. What to find? They want us to calculate the mean diameter of the second spring. So number 1, it will be D2 that we're looking for. Of the sense, if the spring must store the same strain energy, they are saying if strain energy 1 is equal to strain energy 2. That's what they are meaning there. Because they are saying that if the spring must store the same strain energy. That means U1 and U2 should be equal. So that's how you'll find the second diameter, okay? So second number 2. The next question says the maximum load that can be supported. Maximum load, that's that one, that can be supported. So it will be WT. It's the maximum load. We know that they will be the same. So it will be, because W1 is equal to W2. The next question says the total strain energy stored. We are told that strain energy is the same, so we need the total that is stored. Then number 4, they want the equivalent stiffness of the composite spring. Now, obviously, in your formula sheet, there isn't your equivalent strain energy. You can see in your formula sheet that we have KE. That's why we say equivalent, KE. But we know that since this is connected in series, so KE that we will use to be the one for series, which is this one, KE. So they are looking for KE. That's the equivalent stiffness. Right? So number 4, it will be that KE for a conbro, yeah, for that connection. All right, let's go ahead and try to answer it. Remember, we are told that those strain energies are the same. So that means for number 1, we'll have for U1 equaling U2. We'll go to the formulas for OU. So a formula for U, another one is this one, but we do not have K as yet. We do not have X neither. Do we have W? No, we do not have W. So we don't have W. So that means the one that we will use, it should be this one. Okay, we do not have W, but we are saying they are the same. So that means for W, we know that they should be the same. So W, they can cancel out right there. And then we'll be left with D cubed, and G will be cancelled out as well. So over D. All right. So for this to be the same, we will have D cubed times N. This is for 1 divided by small letter d, 1 to the power 4. They should be the same. D cubed for root 2 this time, and 2 over small letter d, 2 to the power 4. Then we'll just do a substitution because we have n2, 15. We have small letter d2 is 3. The only unknown is that d. Therefore, d2 will equal. Then this will go to the opposite side and multiply. This will go there and divide. So in other words, we'll have small letter d to the power 4, d2 to the power 4, then d cubed, d1 cubed, and 1 divided by, then we'll have d1 to the power 4 times n2. Now remember, this d is cubed, So that means we look for the cube root of that. So that's how to answer it. Get the answer, and that's it. I hope it makes sense. If you have questions, you can ask. I'm still available. I'm still available. Okay, let's move on to number two. Number two. So the second question. Okay, let me just wait for a moment to ensure that no one has questions. Okay, second question, it's supported. So in this case, you have to calculate both just to be sure. Just to be sure, you can calculate both. And let's check what we have. We have this, we don't have x, okay. So which formula can we use if we do not have x? We do have this one. We do not have x. If we do not have x, we can use that. Then we just ignore the k because k will cancel out anyway. So we can use that one. So let's use that one. We have this. Yeah, we have the share. We have W. Okay, we are looking for W. We have that one. Okay, will not be there. So we can use that one for W1 and for W2. We just check if they are the same. They are saying look for the maximum. You know most. You're still remembering that. So is equal to 8WD over pi d cube. Then we are making W the subject of the formula. This will go and multiply. So we have pi d just divided by 8. Okay, if you want to, you can name cube 2 now. That's what for this one. Any questions? Does it make sense? Okay. All right, let's move for the total strain energy, that is dot. Okay, let's go ahead and find it. Number 3. Remember, we said, or we're told that U1 is equal to U2. So that means we can only calculate one U. If we calculate that U, you just multiply it by 2 because we know that they are the same. We were told that they are equal, isn't it? We do know that U1 or U2, anyone you prefer to calculate, it doesn't really matter which one. You can use that formula, but this time you'll add the missing links as well, which is that 4w squared d cubed n. So if you're using 1, it will be 1, 1 throughout, divided by, it will be g d1 to the power 4. Then you calculate, find the answer. Then for ut, it will equal to u1 plus u2. But remember, u1 is equal to u2. That's what they told us. We use that information there, isn't it? We use that information there. That is why we found that D2. Because of that information, U1 is equal to U2. So we will apply the same thing here. Then we get the answer, which is equal to O2 U2. It doesn't matter about quickly usebenzisa AP. Anyone will be acceptable. All right. Any questions? You can send them in the chat box. I'll look at them. Okay, now let's move to number 4. If there are no questions, I'm moving to number 4. Number 4 says that we should calculate the equivalent stiffness of the composite spring. I told you the equivalent stiffness is this one. This is the equivalent. All right, yeah. That is the equivalent. So this is it. All right. So we're going to use that one to get it going. So let's go ahead and do it. Let me go and find K1, okay, of K. K is equal to this. We do have all that information, so we can use that to calculate K, or K is equal to that. So you can use any of them, but since we do not have X, we'll use this one. So let's go ahead and do so. G to the power 4. Okay, so you'll get, this is 1, this is 1, this is 1. So you can use 1 and get the answer for K1. They'll do the same to find K2. G D to the power 4 over 8 D2 cubed N2. Get the answer. Then after that, you'll have the equivalent. So the equivalent will be, as you can see, K1 times K2 divided by K1 plus K2, and get the answer. Are you seeing that? So that's how you'll get it. So this is how we will go about solving a problem like this. So most of these problems, as you can see, they ask you one thing at a time. So yeah, you can see, you can find that one thing at a time in that way. Now, if you go to 120, that one, but I want to show you something. To number 120. Okay. So in 120, with a closed coiled helical spring consists of 12 coils of a wire diameter of 3 millimeters and a mean coil diameter of 25 millimeters. The maximum allowable deflection of the spring is 14 millimeters. For the material, okay, yeah, G for the material is 80 gigapascal. So that's what you have. Now, I said that this one, I'm not going to do it per se, but what I will do instead, I will just, because it is the same procedure, will follow the same steps basically. For example, they are asking the allowable load. Obviously, it is W. For number one, they're asking W. Or let me quickly take down the data. So for 120, it's a closed coil. It consists of 12 coils. So that means the data, we have 12 coils, which is N. Then the wire, that means D, small letter D, is equal to 3 millimeters. And the mean diameter, that means the capital letter D, is 25 millimeters. Then the maximum allowable deflection of the spring is 14 millimeters. That's what you have. So deflection is X is equal to 14 millimeters. Then finally, they are having G, which is equal to 80 gigapascals. So that's what we have. Then we have number one, which asks for a load. Find number one is the load. Then number two is the maximum shear in the wire. Then number two is the maximum shear in the wire. Then number three is the strain energy absorbed by the spring. So do we have a strain energy absorbed by the spring? Yes. Number four, they want the stiffness of the spring. So the stiffness is K, isn't it? Then number five, finally, the angle of twist. Now that's the one I'm going to, the angle of twist. So the angle of twist is the one that I think is a little bit different. So for the angle of twist, that's when now you will need to go back to those notes, to those ones that I said you should highlight. Then now, because it's not in your formula sheet, but now that is the formula for it. So you can have to memorize those ones as a red. That's why I said can memorize the red ones because they are important. So that one you need to memorize and then answer it that way. I don't know why it went. Oh, I think it's battery. But I'm back now. I'm happy. I'm back again. All right. So let's continue with what we're doing. Now, 20, I said that I'm not going to do 20. Maybe I can do 21 because maybe it's asked in a different way. Then someone asked for 23. Okay, I'll also try to do 23 as well. Yeah, so we will do 21 and 23. Yeah. Okay, let me quickly go through 21. So 21, I'll take fresh data. So that one, the source data is no longer available. So let's go fresh data. One, I'm gonna do 21, guys. So this, since they are connected in series, one spring is made of steel and has 10 coils. So now we are told that they are not the same. Like the material is not the same. The one spring is made out of steel and the other is made out of bronze with 12 coils. The total energy absorbed by the composite spring is 2 joules. So that means that is U total. And we know U total is equal to U1 plus U2. Both springs have the same spring index. All right, what is the spring index? Spring index, it is that C that we referred to, that we used to calculate, to find the, when we needed to find the K, we used to look for that C. So that is the spring index. They're saying it's 8.2. That is why it does not have any unit. It is because it is a ratio of the diameters. Then they're saying take the steel stiffness and modulus of rigidity as 12 kilonewtons per meter. They forgot to write per meter. You add that per meter right there, guys. That's a mistake. Per meter, that is 21. So that is per meter, 12 kilonewtons per meter, and 80 gigapascals respectively. And the bronze stiffness and modulus of rigidity is 6 kilonewtons per meter. Okay, let me actually take it down. So we have number 1, N for steel. So N for steel is 10. Then we have N for brass, which is 12. Then after that, they are saying the total energy absorbed. So we know that U total is equal to 2 joules. Then they are saying that when both springs have the same, that is C is equal to 8,2, the same C or the same spring index. Then they're saying take the steel stiffness and modulus. So is stiffness, we know that is stiffness, it is K. So K for steel is equal to 12 kilonewtons per meter. They didn't write that per meter. I have to write it for you. Then they are also saying G. We have to find the one for steel, weight for steel, that brass, that's number 1. Then number 2, they are saying that the wire diameter and main coil diameter for each spring. So meaning that you must find number 1, small d for steel, small d for brass, and big D for steel. We know that we can use different types of formulas, but the one that is easiest, I'm not really going to show you those formulas as okay, or let me continue doing. Of course, you can see this one, but now I made Now, remember they are saying that we need those ones, so that is what we will have to find them. And then we know that this is the equation that we took 1. Okay, so how are we going to get that? Then we need to find these two. Actually, that is the total. Yes, because that's what they want. So let's go ahead and find out how are we going to do that, because remember, for series, W1 should equal W2, isn't it? So that's what we will have at the end. So let's go ahead and find out how can we get this one. Of course, we use the series formula, which says K S KB over KS plus KB, then that is KT, the one we'll put there. Then you'll find the answer for it. Then for XT, so for XT, we will use, okay, for example, we'll use UT is equal to KTXT squared over 2. We have U, we have K, we only need X. Therefore, XT will equal 2UT. We were given UT. There is UT divided by KT. So it's square root, then you find that XT. Then after that, you take these two values, KT, put it there, XT, put it there, get the weight. That's how you'll get it. That's it. Then also for number 2, it will be a similar process, because now here they are asking only 2 questions, but there are steps you need to take to go and reach what they're asking for. So I want you to open your mind also on that note in this one. So they're saying the wire diameter of the mean, the wire diameter and the mean coil diameter of each spring. So now we'll follow similar steps. For example, you have K, maybe let's say KS, doesn't really matter. So say KS will equal to GSD small d S square to the power 4 over 8 ds cube NS. To find this D, so okay guys, let me check something out. Let me just check something. Thinking. Before this, the subject of the form, you need to say, before this, the subject of the form, you need to say G over small d, this thing cubed. So that's what I have here. Like this is ds divided by 8c cubed ns. So this is what we have. Then I can substitute because I do have OC. They gave us OC being 8.2. So I do have OC right there. I can put OC there and then make that D as the subject of the formula. Okay, then when I make it the subject of the formula, I'll have ds is equal to, now on this side it was ks, so this will go and multiply just ks times 8 times c cube times ns divided by gs. Then you get that value, you get the answer. Then afterwards, for you to find capital letter D, therefore capital letter D, we'll use the same equation. This time you're going to multiply by that D there to get the capital letter D. So it will be ds times C. Then we'll get that D. You will apply the same skill for OK B. Again, for KB, it will be like this. GS ds over 8 C cube and B, sorry. Yes. Then after that, you can make that the subject of the formula, therefore small 8KB. So then you will be able to find that dB, and then also for a capital letter D, it will just be this dB times C. So I thought I should also show you this particular example just so that you can know how to try. We have a special question. Okay, but are there any questions on this one? Now that I've finished it, any questions about it? Okay, I'm still around, guys. Don't think I'm gone. I'm still here. Okay, then let's go now to 120. Try to work with that one and see how are we going to find their solution. So this one, and then it is clear and straightforward. There's number 123. So I'm going to do number 123 as well, so that flow together. Score to second, I hope. All right, so let's go to number 23, which is a buffer. Now, when the buffer is safety buffer, okay, it's a series with trains. So now there'll be this to stop that train, so it will move to those springs. Okay, aluminium, it will act as a spring. So this train will have to go and be stopped by those springs. So that is what is known as a safety buffer. So this part, this finger, will be the safety buffer, so that this train may not crush other things. So it will be stopped by those springs and then it will bounce back. So that is a safety buffer. So let's go ahead and answer that. So we're told that a safety buffer must stop a loaded goods carriage with a kinetic energy of 1 kilojoule. So they gave us the energy of that. Our U is that U, because I said that U is the energy. That means that is the strain energy, that kinetic energy that is given there. It is our strain energy total. Then it says now the buffer consists of 15 identical springs placed in each with a stiffness of 2 kilonewtons per meter, that is K. Then they say, and a spring index of 10, that is C. Shear stress in wire may not exceed 80 megapascals, and the modulus of rigidity 75 gig. Let's go ahead and do that. Let's take down the safety buffer, a range of good, reach which of, so that is U, so that's date U is equal to 1 kilojoule. Then we are told that the buffer consists of 15 identical springs. This N will be different. This one number springs. I can say capital N and caution that will make, or let me say, so that is the number of spring. So that one, it will be 15, because it's different from N as the number of coils. So it says the stiffness is K. So it is 2 kilonewtons per meter. They wrote it correctly. And a spring index. What is the spring index? It is C. So they're telling us C is equal to 10. And C is a ratio, so it does not have a unit. Then they're saying the shear stress in the wires may not exceed 80. So we are told it 80 megapascals. And finally, what is the modulus of rigidity is 75. So that is G. Modulus of rigidity is G. Find number one, the compression of the buffer. That means how it hits, that compression it hits. One, they want deflection. That's number one. Then I can maybe say it is the total deflection for the whole thing. Then number two, they are saying the diameter of of the spring wire. So that means they want a small d if they're saying the diameter of a spring. The number of coils, exactly why I had to mention that this n is different from this n, the spring, isn't it? For each spring. Then after that, number 4, they want the length of fully compressed spring if it has 2 inactive coils. This also is a different note, because I think I saw it in the of the notes. I didn't see it on the notes. I only saw it in an example. If you can another example now. In your textbook, let me just check that example. Where is that example? I saw it in an example. It did not give me a straightforward thing. Or they gave us a yes, that is a solid one. For example, example number 1 in your textbook 7.1, example 7.1, the very first example says the load applied on the spring. Then the things that they are calculating, they said by calculating the deflection, then they calculated the number of coils. They are saying solid, L solid divided by D to find the number of coils. Now, in this case, they are saying there are 2 inactive. So that's the difference. So that means even though there is a formula there, now we'll use for that. It's not in your notes. It's not as good. It's not as good. But yeah, we will try. The formula that we'll use uh, for question number 4, because question number 4 wants the length of a fully compressed spring. So this is the formula we are going to use. Of course, it's not in your textbook, but you can add this formula because it is also needed. The one that is in your textbook is the one where there are no inactive springs, because it says here there are 2 inactive. So since it says if there are 2 inactive coils, so I have to add that 2. If there will not, it's just going to be ND. All right. So the formula is there. So let's go ahead and work this out. So how are we going to calculate X? So is the X for the whole thing is total X. So if it's total X, we need to look for the formula for that. This is the formula. We have X, we have K, we have W. We need K for the whole thing, or we can use this one. We have U, we do not have W. But if so we have U for the whole thing. We have UK for only one spring. So we need UK for the whole thing. Then we'll use that X so that we'll be able to find that X, the X value for the whole thing. So let's first get K for all. I'm going to add them. If they are saying they are 15, that means you're going to multiply that K by 15 because we're using for parallel connection. So K should be 15 of that. All right. So we have U is equal to 15 because this is U total. That is U total, that one. It is U total. Then you are saying X squared because even the X is a total divided by 2. So now we're going to make definitely X the subject of the formula. So obviously, since it's squared, we'll have a square, it will be 2ut of K. Then you're going to substitute for to get that X total. You'll use that formula to get it. Okay, then let's move to the second one. Second question. The second question wants the diameter. It wants the diameter of the wire. Now, it also said that the diameter of the spring wire by using K when they are saying walls. So that means when your walls gave us to see, isn't it? They said, okay, I'm back again. Hey, this network is it's making funny things, man. It's making funny things now. I really don't like what it's doing. Because now I will say this and I'm not sure who's seeing it. We have K, we have W.